All right, good morning. We're gonna be graphing cosecant and secant today. All right, to make the video a little bit shorter, I already have a skeleton of the notes. All right, so let's go ahead and graph the parent function of cosecant. So f of x equals cosecant of x. All right, in order to graph cosecant, we need to know that your cosecant is 1 over your sine of x. Okay, so we're gonna be using, just like when we did with cotangent, now we're gonna do it with cosecant. We're gonna do 1 over sine of x. Oh no, we didn't do it with cotangent, sorry. So cosecant is 1 over sine of x. Okay, so let's do it. Okay, so we're gonna make a tiny little unit circle. And don't forget that we're here at 0. We're going to do pi over 4. Just like tangent and cotangent, we do multiples of 45. All right, and I went all the way up to 2 pi. But remember, later we can do shortcuts. Once we know one cycle, we can do a shortcut. Okay, so the next one will be 45. Then we do 90. Then we do the other 45. Then we do 180, then we do the other 45, then we do 270, and then we do the other 45, okay? So over here, and we just care about sine. So this will be 1, 0. So this is my sine. This will be 0, 1. So this is my sine. We don't care about cosine right now. This is my negative 1, 0. So this is my sine. This is my 0, negative 1, and this is my sine. And over here, remember, is sine cosine of 45 is radical 2 over 2 and radical 2 over 2. So this is my sine. And if you divide radical 2 by 2, the decimal is about 1.4. Okay, so we're going to be using the decimal. And then it will go around the unit circle. In some cases, it will be a negative, because if you're in quadrant number 3, it will be a negative, because sine is negative and cosecant are negative in quadrant number 3. Okay, so that's how I got these values right here. This is my x and this is my f of x. So cosecant of 0 is 1 divided by your sine of 0. Sine of 0 is 0, so 1 divided by 0 will be undefined. So cosecant is undefined at 0. Pi over 4, this is your sine. So cosecant of pi over 4 is 1 divided by your sine, so it's just going to be 1 divided by 4, okay? If you do 1 divided by radical 2 over 2, you're going to get 1.4. So just believe me and memorize that cosecant of pi over 4 is 1.4. Actually, I'm pretty sure you guys are not going to believe me, so let me do it. So 1 over. So sine of pi over 4 is radical 2 over 2. So it will be 1 times the reciprocal. So it will be 2 over radical 2. If you rationalize the denominator, you get this. So you just do radical 2. So the square root of radical 2 is just 1.4. Okay? So that's how I got that 1.4. At pi over 2, it will be 1. So 1 divided sine of 90 will be 1. So 1 divided by 1 will give you 1. 3 pi over 4 is 1.4. You're in quadrant 2, so quadrant 2 is positive. Your sign is positive. At pi will be undefined, because we do 1 divided by sine of 0, it will be 0. So sine of 0 will be 0, so 1 divided by 0 will be undefined. And then we go to quadrant number 3. So quadrant number 3, over here, your sign is negative. Right? Both of them are negative, so sine will be negative, so negative 1.14. 5 pi over 3. We're here, sine, so sine of 270 is -1, so 1 divided by -1 is -1. And then we do 7 pi over 4, 1.4, because over here your sign is negative, so it'll be -1.4. And then undefined, okay? And then we graph. So let's do the undefined. At 0, it will be undefined right here. Then my next undefined will be at pi, right here. Then from 0 to pi is 180 degrees. So every 180 degrees, I will have an undefined. So at 2 pi, if I go left, at negative pi, I will have one undefined, and at negative 2 pi, I will have another undefined. All right? Then I plot the points. So 0 undefined, pi over 4. So this is my pi over 4 is 1.4. So 1.4 about here. At pi halves will be 1 and then 1.4. And yep, it's a parabola. And then if you go to the next undefined, over here at 5 pi over 4 will be -1.4 about here, here, and here. And this one opens down. So it's a pattern. See? Opens down, up and then down. Then if I want another one, my other one will be right here. And then it will be my undefined. So on the left, it cannot be 2 in a row, cannot open up. So see, up, down, up, so the other one has to be down. And then the next one is up. So this is 1, 1.4, 1.4, and opens up. And this is the reciprocal of sine, which is cosecant. Okay? We have I can show you a trick. I'll have to graph it by graphing sine, and I'll show you after I'm done with the transformations, okay? All right, so the period, so the formula to find the period is P equals to pi divided by the absolute value of B. In this case, there are no transformations. B is 1. So the period of the parent function of cosecant is 2 pi. Your domain, let me make it smaller so you can see. So the domain will be any real number, comma, x cannot equal to, so the first undefined is 0, plus all the every single time that you see undefined. So I have it undefined at 0. My next one is at pi. The next one is at 2 pi. So from the distance from one undefined to the other one is 180 degrees, which is pi n. Okay? Oh, by the way, the period of cosecant is one cycle is 1 up and 1 down. That's why the period is 2 pi. See? 1 up and 1 down. This is one cycle. Okay, 1 up and 1 down, this is another cycle. So the cycle, the distance is 2 pi. It doesn't matter, you need 1 up and 1 down. 1 up and 1 down, so the distance is 2 pi. So that's why the period is 2 pi. I remember when you guys told me, oh, so when we do the domain, we use the period, and I said no. Because in this case, it doesn't work. See, over here the period is 2 pi, and over here the distance from one to another undefined is pi. And that's the reason why I told you no. So don't make that assumption. All right, the range. The range has a restriction too. So the range is bottom to top. So we're coming from negative infinity, and we hit the maximum of this one is -1. You're including the -1, and then you put union, and then you go to your other minimum. So the minimum is at 1. See, you go over here. So over here you have a break from -1 to 1. There is a break over here. So the next one starts at 1. So bracket, comma, infinity. And that is the range of your cosecant. There is no amplitude, just like tangent, cotangent, no amplitude. And I told you no amplitude for tangent, and guess what? You wrote the amplitude on your quiz. Midline, it has a midline is y equals 0. And let me talk about the midline. This is the midline. From the midline, see how this is a minimum? So it's the same distance from the midline to the minimum, then from the midline to your maximum. This one has a maximum, this one has a minimum. And from the midline to your minimum is the same distance as from your midline to your maximum. So pay attention to that, because you might get it wrong when we do transformations. It will shifting up and down. All right, let me show you the trick, okay? When you graph sine, this is the parent function of sine. All right, so the parent function of sine, remember, is 0, 0. Pi halves is 1, then 0, then -1, then 0. Okay, so this is my sine function. And I can continue. And over here, I'm gonna do maximum, minimum. This will be 0. This will be 1. This will be my maximum, and this is my 0. So this is sine that. So if you graph the sine function, so where your sine function and the midline intersect, see where the line, where your sine graph, the graph of sine, and the midline intersect, you always have an undefined. See, where the function, I can't even say it, where the graph of sine and the midline intersect, you always have an undefined all the time. And then your maximum of sine will be the minimum of your cosecant. And then you just add that 4 over here, see? So this is 1.4. So the minimum of your sine will be the maximum of your cosecant all the time. So that's a trick that we use. We graph sine, and then from sine, we get cosecant. And I'll show you what I'm talking about in a problem later, okay? So those are the key features, and that's your graph. And let me graph now secant, okay? So same thing for secant. You should know that your cosine is 1 over secant, okay? Sorry, and we're not using that one. We're using this one right here. I circled the wrong one. So from your cosine, we get 1 over secant of x, okay? All right, and the same thing happens at cosine and cosine at 45. They're exactly the same thing, so pi over 4 will always be 1.4, okay? If we're talking about secant. So let's go ahead and go over the unit circle. So now I care about cosine, okay? So now I care about cosine. I care about my x. So if I do cosine of 0, it's the same thing I'm doing secant of 0. Now I do, sorry, yes, I circled the right one. Let me go back. No. Okay, there. Let me erase this so you guys don't get confused. Okay, so if I want to do secant of 0, I do 1 over cosine of 0. Okay, so cosine of 0, it's 0. No, cosine of 0 is 1. Therefore, secant of 0 is 1. That's how I get that 1. Then if I want to do at 45, so cosecant of 45 is 1 over my cosine of 45, right? So cosine of 45 is radical 2 over 2. If I do the division, well, how come that's not, if I do the division, that will be 1 divided, so you multiply by the reciprocal. So it's 2 over radical 2. If you rationalize the denominator, it will be 2 over radical 2 over 2. You cancel the 2, so radical 2 is about 1.4. And that's how we get that 1.4 after I do all of this. So it's, instead of doing the work, it's easier to memorize that cosecant of 45 is 1.4. Otherwise, you have to do all of this work. Okay, so 1.4. And now at 90 degrees is undefined, because if I do 1 over cosine of 90 is 0, so 1 divided by, cosine of 90 is 0, so 1 divided by 0 will give me undefined. And then I continue, I go around, so at 45, because cosine in quadrant 2 is negative, so negative 1.4. At pi will be negative 1. At quadrant 3, cosine is negative, so negative 1.4. Then it will be my undefined, because it will be 1 divided by 0. Quadrant number 3, right? Is positive, no 4. Is positive. Quadrant 4 is positive, because you do 1 divided by 1 is positive. And at 2 pi, we go back, and it's a 1. Okay? So that's how am I getting those values. And if not, use a calculator to find the values. I show you already how to input cotangents, the same thing. There is no key for secant, so when you input secant, if you want to do 1 over cosine of 0, and you're going to get a 1. 1 over cosine of 45, and you're going to get 1.4. 1 over cosine of 90, and you're going to get error undefined. And then you can get these numbers also by using technology. But it's easier if you start memorizing. Okay? Let's do the undefineds now. So my graph is undefined at pi over 2, 3 pi over 2. That's it, right? So find the distance. So 3 pi over 2 minus pi over 2. So we have a same denominator, so 3 pi minus pi, 2 pi divided by 2, so pi. So every 180 degrees, you're going to have an undefined. So this is 90 plus 90, so my other undefined will be here. My other one will be here. And if I want more, my other one will be right here, see? So when you get used to it, the trig functions are very easy to graph, and I'm not lying. And you might say, oh yes, but you're the teacher. But when I learned it, I wasn't a teacher, and it was easy. Once you start doing your homework, everything becomes easier in this life. When you practice, everything is easier. Okay, so let me graph. So 0, 1. So 0, 1. Then pi over 4 is 1.4, so that will be 1, 1.4, and my other one over here, see? Then at pi will be negative 1. Why did I plot the point over there? I have no idea. So it's right here, oh. And then 1.4, 1.4, and goes down. So my other one has to open up. And I cannot do one here. You cannot have 2 in a row that open up, okay? So that's how you know if you're doing it wrong. My other one has to be right here. Just follow the pattern. And then my graph. A period. So a period is all of this. So find a distance. For those of you that have a hard time with a period, you go 3 pi over 2 minus a negative pi half. So minus a negative minus plus. So it'll be 3 pi plus 1 pi, 4 pi divided by 2, so it will be 2 pi. Or you can also use a formula. So the formula is the same as your cosecant, sine and cosine. The period equals to pi divided by the absolute value b. Your domain, any real number, comma, x cannot equal to, my first undefined is pi halves, plus from one undefined to the other one is 80 degrees, so pi n. My range, bottom to top, negative infinity, comma, to -1, bracket, union, bracket, 1 to infinity. Oh, and I forgot to tell you that there is another way of writing that range. You can also say y is less than or equal to -1, all right? Or y is greater than or equal to 1, okay? This is how I wrote it in your formative, this way, okay? But this is another way of writing it. There is no amplitude, and the midline is y equals 0, and there are no transformations because we just graphed the pairing functions. All right, and also I forgot to tell you that for this one, the domain, you can also do it like I showed you before. Any real number, comma, x cannot equal to pi n. All the multiples, because the first undefined is at 0. We remember we don't have to write it, but if you write it, don't forget it's not wrong. If the computer tells you that it's wrong and you know that you're for sure you're right, sorry. Send me a message. I'll be checking this tomorrow, okay? I don't know what time, but I'll be checking. So if you send me a message in the morning, don't expect me to reply right away, okay? I'll be busy. All right, I wanted to show you how to graph. Have to use the trick of graphing, okay? So let me see. So let's say that I don't want to graph cosine. So I'm going to show you with cosine. I already showed you sine. So let's say that they gave me g of x. When I'm recording, this happens sometimes. G of x equals secant of x. Okay? But I don't want to graph that one. I want to graph cosine. Okay? So let's say that cosine is +1. So cosine of 0 is 1. If you shift it, it will be here, because your midline will be this one. Cosine of 90 is 0, but if you shift it, 1 is here. Okay? And then cosine of pi is, remember, that's 0, 1 is going to be, it's going to be -1, but if you shift it, will be your 0. This will be here, and this will be here to pi. Yeah. So this is your cosine shifted 1 unit up. And then don't forget that cosine is reflex across the y-axis. So that's it. Okay? So they say they gave me this, but I don't want to graph this one. I already know how to graph cosine and it's easier. So I'm gonna, if this is given, what I do, this is the trick that a shortcut trick, call it whatever you want. So this is what I do. I grab my cosine, and every single time that the graph of cosine intersects the midline, you have an undefined. So every single time that the graph of cosine intersects the midline, you have undefined. So you do have to graph the midline. Okay? Then the maximum will give me, see, the maximum will give me my parabola that opens up, and this is just that 0.4. Then over here, the minimum will give me, it's just 0.4, because it's 1.4, so it's just, And then if you don't want anyone to know that you use your cosine, you can always erase that evidence. And this is a trick of graphing secant and cosecant. If you don't like it, don't use it. If you like it, use it. Okay? But we do get secant from the graph of cosine. It's faster because we don't have to do the multiples of 45. We just do multiples of 90 for cosine and sine, and that's how we get the reciprocals. All right? So it's just showing you little tricks. All right, let's go ahead and graph this function with a transformation. 2 times cosecant of x plus 1. So I'm going to graph this one because it's a reciprocal sign. And I already have it here, see? I already have it with a transformation. So sine, it's sine of 0 is 0, pi over 2 is 1, pi is 0, 3 pi over 2 is negative 1, and 2 pi is 0. So if you multiply times 2 and add the 1, these are the transformations already. So I already graphed my sine, and this is my midline. My midline is y equals 1. Okay? I was supposed to get rid of this to show you. I'm reusing the notes from last year, but I forgot to delete this. Shh. Don't tell anyone. It's a secret. Hold on one second. I think I'm gonna leave that one, just tell you, because otherwise it's gonna take forever and I wanna finish this video. Okay, so I already told you that where your sine intersects the midline, you have an undefined. So at this point, my graph intersects the midline, the blue one, so that's why I have an undefined, see? Then I follow my graph. So this is the midline, so here I'm intersecting the midline with my graph, so that's my other undefined. And over here, I have another undefined. And over here, if I go left, that will be my other undefined. And if I keep on going, I will have another one, okay? So I already did a transformation. So I already shifted my 1, multiplied by 2. So this is my maximum over here. I'll just have to add that 0.4. Look. Over here I have my minimum. I just have to add that 0.4. And over here, same thing. Okay. And then I already graph this one. And I don't have to use multiples of 45 because my multiple of 45 will be right here. And I know that is 0.4. Remember, 1.4. But this is my 1 and this is my 0.4. Okay. So let's do domain. So my domain, all real numbers. X cannot equal to, so my first undefined is at 0. Plus, from one undefined to the other one is a pi n. And don't forget that you can get rid of that 0 and just put x cannot equal pi n. Okay? Range, I'm coming from negative infinity. And I am stopping at what point? Negative 1. Bracket. Union 3 to infinity. Okay, and that was supposed to be a negative 1 over here. Yep, midline, amplitude, none. Midline, y equals 1. Transformations, I'm just going to say them, I'm not going to write them. Vertical stretch by a factor of 2 and translate 1 unit up. If there is a b, don't forget that the b is going to affect the period, so you divide by b, so it can be a stretch or compression. And I don't think I need to go over too many details. Honestly, for this, I just care that you know how it looks, the parent function. I really don't care too much about being too specific at transformations. All right, so that's it. You have a formative, so don't forget formative. And I hope that you have finished your Matthias, and I'll see you on Thursday for, I'm pretty sure you're going to have a lot of questions, which I don't mind. I can spend that whole period answering questions if you wish. So save all of your questions for Thursday. Write them down, record them, do whatever you want, but make sure that you have questions, all right? I wish you the best day ever of your life, and make sure that you do your homework, okay? See you on Thursday. Bye.